Hey guys, welcome back everybody. Hey Viru, it's been long time, man. Okay, guys. So what we have done, let me quickly recap. So we have covered the HSRP protocol, if you guys remember that. So HSRP comes in the FHRP. So under the FHRP, we have a multiple protocols. We can see the multiple redundancy protocol, right? Again, make sure that it's not a routing protocol. So I have seen the many resumes, the people are putting the like in the section of the routing protocol, they put the HSRP and VRRP. So HSRP and VRRP and GLBP is not a routing protocol. It's a FHRP protocol. We can see that it's a redundancy protocol. So we have seen the HSRP. In HSRP, we have seen the poop masses, right? If you guys remember that, we have seen the hello packet as well, and we have seen the design as well, right? Then after that, we have also seen how to configure the HSRP depend on the iOS by iOS, right? Operating system, we can call it. We have a different ways to configure the HSRP. If I talk about the iOS perspective, right, that we are learning right now. So in the iOS perspective, you just need to go under the interface and just say that, hey, listen, I'm gonna enable the HSRP. Just put the standby one. That's a group number. You can use the any group. So if you're gonna use the version one, you can use the group. You can use the group from 1 to 55, right? If you know version one, if you have a version two, then you can use the group version 9 right? So in the version two, you have MD5 authentication as well. In the version one, we don't have MD5 authentication. So then you can put the IP address, the IP keyword itself gonna tell you you are gonna use the IPv4, and then you simply gonna put the virtual IP address, whatever the virtual IP address will be. So this IP address will become the default gateway of your PC, right? After that, if you wanna enable the permission, by default, the permission is disabled for the active router, but it's enabled for the standby, right? So if you're gonna enable the permission for the standby, then you can also enable, sorry, if you're gonna enable the permission for the active router, you can also enable it. And then you can define the priority to make sure that whenever this router goes down, it's whenever it comes back, it always go with the active router, right? So the active router is gonna give the ARP reply packet. So whenever the user will request for the ARP request, so active router will give the ARP reply. So in this HSRP protocol, what happened? One router, for example, we have router number one, we have router number two over there, and we have router three, right? So in the HSRP protocol, what happened if we're going to enable the HSRP over there? So one router will become the active router, right? Another router will become the standby router, and the remaining all the router will go in the listen router, right? That's the HSRP. But the problem with the HSRP protocol is what? The major disadvantage, if I talk about the major disadvantage, that's the major one. The major disadvantage of the HSRP protocol is what? It's a Cisco proprietary protocol. So if you have a Cisco vendor, like for example, router one and router two, router three, all these routers are the Cisco routers. You can go with HSRP, there's no issue. But take example, what happened? If you have a different vendor, for example, if you have router one, if you have router two, and if you have router three over there, and they are running with the different, maybe they are running with a Cisco, they are running with a Juniper, because in the production network, what happened, you may find the different protocol, different vendors of the router. You see, majority, if I talk about, so Cisco has a major play role in the market right now, almost 80% market of the Cisco right now. Okay, but right now, if you see in the market, the Arista comes in the picture, right? The Juniper we have, Huawei we have, right? HP we have. So on that router, you can also enable the FHRP, but you cannot use the HSRP in that case. You have to go with the next protocol that has a VRRP over there. So the major advantage, if I talk about the major advantage of the VRRP over the HSRP, it's only a IEEE standard protocol. Now, if I compare with the another thing, right, HSRP to the VRRP protocol. So in HSRP, right, we have a permission is disabled, right? By default, the permission is disabled in the HSRP protocol. Whereas if I talk about the VRRP, the permission is enabled. So you don't need to put this command. You don't need to put this command. By default, the permission is enabled over here in the VRRP protocol. Second thing is that in the HSRP, what happened? If you see, this was the first, the Cisco priority protocol. It's IEEE standard protocol. Second thing is the permission disabled. Second thing is the permission enabled in the VRP. The third thing, if I talk about, right, the HSRP is a little slow protocol than the VRP. So HSRP is a hello second is a 3 second is a hello timer, and that is a 10 second over there, right? But if I talk about the VRRP, right, VRRP is a 1 second is a hello timer, and the 3 second is a dead interval. So VRRP is a little faster than the HSRP protocol. But apart from the, like, what we call the function, right? Same functions are there. In a VRRP, the terminology is changed, right? We have a master and backup role. So one router will become the master router. For example, router 1 will become the master router, right? So router 1 will become the master router who has a higher priority, right? And the remaining router will go with the backup. So one be master and then will go with the backup router. So in the HSRP, we have active, stand, and listen router. In this one, we have a master and all the remaining router will go in the backup mode. So if the master goes down, another backup router will become the master router. So first it will look for the priority. If the priority get high, which is by default 100, right? Then it will go with the higher IP address. Right? Same concept, same virtual IP address we have. The command is very simple. Let me show you this. So if you go on the router number 1, so if you see, do show run interface 0/0. So right now we just have all this configuration. We have discussed this configuration. Let me show you that. Do show IP interface brief on the router number 1. We have this configuration router 1. On router 2, if you see that, the uplink, you can see that the uplink we have a 10.subnet, and the bottom link, right? The access side we have a 191.1.0 subnet, right? Same thing if you go with the router 3 right now. So IP interface brief, I have 1.3 and 37.3, right? So let's go on the router number 1 now. And on router 1, what I can do, that interface 0/0. Simple command, right? So instead of doing the standby keyword, we just need to put the VRRP keyword. And define the group number. I have the group number 1. And now we can put the IP keyword. Define the whatever the IP address you want to define. So it's the 191.1.100. That's my virtual IP address. Same thing on the router number 2 now. Interface 1/0 VRRP IP. And here, if you see that in the HSRP, if you guys remember that, we have a learn keyword over there, right? Not learn keyword, there is also simply enter keyword. You don't need to define the IP address. If you define the IP address on the active router, right, then standby router, what they can do that, they can learn the IP address from the active router in the HSRP protocol. But in the VRP, we don't have this concept. We need to define the manually. And R3 as well. That's all. So if you see this router 1 will go to the master router because right now, then it's jumped to the backup. Why? The reason is that first I have enabled the VRP on this router. This guy has a higher IP address 101. So this guy will become the master. Then what happened? Once I enable the router number 2 and router number 3, then what happened? Router 3 by default preemption is enabled, right? In the VRP protocol. Router 3 can preempt this guy. Hey, one thing, mine is a higher IP address. You have a lower IP address. So I will become the master. And you guys go with the backup. So previously, initially, what happened? Router 1 was a master router. Now what happened? Router 3 can become the master router. The reason is that because of the higher IP address. Right? If you want to make the R1 as a master router, right? If you see right now, do show VRRP. So you can see that this is the master router. This is the virtual IP address we have. That's a virtual MAC address. The last 01 is going to represent the group number. The group number that you have mentioned over there in the configuration part. So by default, preemption is enabled and priority is 100, same like HSRP. But in the HSRP, the preemption is by default disabled. The hello time and the dead time is the 1 second and 3 second. Same thing if you go with the router 3 is a backup router. All good. So if you want to make the R1 as a master, so what you can do that simply VRP 1 priority. I'll make the priority is a 110. I'll make the priority of the R2 is a what? 105. So what happened? If the router 1 goes down, then for example, what I can do that in that scenario, I'll see that, hey, your bandwidth of this guy's are maybe 20 meg link, right? And this guy's a 15 meg link, and this guy's a 10 meg link. So I'll say that, hey, always the router 1 will be the primary router or we can say the master router always, right? And remaining all the router will go in the backup. So if the master goes down, this backup comes in the picture as a master router because these guys are 15 Mbps. So now you can see that router one, it's take the role of the master because of the priority. So the first it will look for the priority. If the priority get high, then it will go with the higher IP address. Anyone has a question, guys?
No, sir.
Great. That's all about the VRP. Now, GLPP is not a part of your syllabus. So I'll just explain you what GLPP is doing that. So the problem with HSRP and VRRP is that if you see the common problem, right? You have a router number one, you have a router number two, and you have a router three. Understand this concept. What's the problem with these two guys? So in a case, take example, router one become the master router, or we can say the active router. The remaining router will go in the backup, or we can say the standby and listen router. So assume that I'll say let's go with a simple scenario. I'll say the master, this guy, and this guy's a backup, right? Backup. So in that case, what happened? Only router one. So whatever the user over here, try to understand this guy, whatever the user we have. So all this user will send the traffic through the router one only. All this user will send the traffic through the router one only because he's a master router. So in that case, what happened? You cannot utilize these resources, right? You cannot utilize these resources. That's a major disadvantage. You cannot do the load. See, I cannot use this terminology. You cannot do the load balancing, but by default, load balancing is not possible. By default, you cannot utilize all the resources. I cannot send my traffic with the router 3, router 2, and router 3 because this is a backup router. With the help of GLBP, right? It's a name says the Gateway Load Balancing Protocol. With the help of GLBP, what happened? You can, right? You can send the traffic by router 1, router 2, and router 3 as well. You can do the load balance. That's how the GLBP is working. So another difference in the VRRP and HSRP is what? So HSRP, it's a UDP-based protocol. The port number is 9085, whereas the VRRP is L3 protocol. That's another major difference. So if I talk about the performance bias, it will take the little more performance, it will take the more CPU than the VRRP. So that's why it's a very good one, IEEE standard protocol. So most of the time, in a production network, you will see the VRRP. The reason is that because in the production, you have multiple vendors of the router. But it doesn't mean that you will not see the HSRP. If you have only Cisco vendors, you will see the HSRP over there. Okay. All good. So the next thing that I'm going to discuss with you guys, that's called as a NAT. Anyone can explain me what is NAT? Anyone has an idea?
It convert the private IP address to public IP address, sir.
बहुत ही गंदा जवाब. So the first thing is that okay, let me write on the sort of one answer. So as per the sort, we say that it convert. So better to use this what it translate, right? Okay, sir.
Yes, sir.
Private IP to public, right? That's your answer, right?
Yes, sir.
Yeah, another one.
The other way around. One public to multiple private.
One public to multiple private. Okay. How are you gonna do that? Many to one is NAT. 1 to 1 is also NAT. So many to one is NAT. Or when the 1 to 1 is NAT also. So the first, let me correct this point to sort of point. Sort of has given the very basic information. That's a good one. Like as per the basic level. We can also say that it translate, right? The public IP to public IP as well, right? Translation is what? I can do the public and see, understand the concept, guys, what's happening over there. So as per this, so I'm not explaining the NAT, what is NAT right now. I'm just explaining the sort of concept right now. Sort of say that it's convert the private IP to the public. I'm not saying the sort of is saying the wrong answer. Sort of is correct answer right now. But let me clarify this thing. So take example, we have a 10.1.1.1.1. This is the private IP address, right? And this is the take example 1.1.1 is the public IP address. So I can say that what happened. So when the router will receive the packet, what router? This is the NAT router. What NAT router will do that? It will convert this private IP address to the public. So I guess the 1.1.1.2 will be converted into the. So this will be converted 10.1.1 will be converted in the 1.1.2. So that's how the conversion is happening according to the sort of. But in the production, right, when you go to the higher level of the NAT, okay, you may see this thing as well. So you have a public IP, right? Here's the router one, that's a NAT router. And you will see like this way as well. Not a big deal. So translation, right? The meaning of translation is what? I can do the public to public translation or I can do the private to public translation. It's totally depend on the requirement. Correct, Saurabh?
Yes, sir.
Great. Next thing, it translates the public IP to not one public IP to the multiple private. Still, I'm getting confused with the word. What is this thing? One public to the multiple private. Oh, got it. So you're talking about the path, right? Got it. So I'll come to this point later. Okay, we do. So many to one NAT is also called as many to one and one to one is also called as a NAT dependent on. So this guy comes in the dynamic NAT, right? And this guy comes in the static NAT. So anyone else get the answer? DSCP is a many to many, static is a one to one. That's a good example. So let's come to the understand the NAT. Why the NAT comes in the picture? See, देखो अगर मैं बहुत सिंपल लैंग्वेज में बात करूंगा, वेरी सिंपल लैंग्वेज. सो IPs जो था, right? So initially, it was not an IP. Initially, it was a CLNP protocol, and CLNP addressing hota tha us समय. On the time of 1970s. It was IP was not a dominant protocol. Like right now, you can say that okay, this PC has a 1.1.1 IP. This PC has a 1.1.2 IP. So this is the IP address that you're defining it. This is basically is what? This is basically an address of the computer. Right. But initially, जब 1970, if I talk about 1970, CLNP was not a, sorry, IP was not a dominant protocol. CLNP was a dominant protocol. But CLNP has its own issues, right? It has a lots of issues. Like in a simple time, when you come to the SP level, then I'll explain what is CLNP. So CLNP is basically, it's not hierarchy. You need to follow lots of hierarchy to define the CLNP addressing. That's why CLNP was not become the popular protocol, and the IP become the dominant in the near around 90s time. So near around 90s time, what happened? IP was a very popular. So everyone was using the IP. So then what happened in the 1994? The peoples are getting people are using the lots of IPs to the everywhere. So initially the engineers, they haven't think that like this will go. Your mic is on. So initially the network engineer or engineers never think that the internet will go beyond that the imagination, right? So in 1994, what happened? IP was exhausted. Exhausted in the sense of what? So every people, right, everywhere the IP comes in the picture. And what is the size of the IP? 32-bit only, right? 32-bit was not enough. So in 1994, what happened? They came with a concept which is called as a private and public concept. They say that, okay, so initially there was no private and public. Initially IP is IP. There was no private and public. Now you can see there are private and public. So in the 1994, when the people are saying that, okay, there is no IPs are available nowadays. So what they will do that, they converted the private and public concept. So when they converted the private and public concept, they say that, okay, whenever the LAN person, whenever the users are in the LAN network, for example, when they want to communicate with the printer, because when they want to communicate with the what we call IP phones, right? And whenever they want to share the anything in the internal database, they can use the private IP. Private IP can be duplicated. But whenever they wants to go, whenever the user wants to go to the internet, they can use the public IP. In that case, what happened? We can save the lots of IPs. Take example of the printer only, right? Imagine in a one company, if we have 100 plus printer, right? How many IP we can save? 100 plus IPs we can save it. Because now we are going to assign the private IP to the printer. Because there is no need to assign the public IP to the printer. Then what happened? To make a communication between now the users has a private IP address, for example, 192.168.101. So the users has a private IP. Now, if this user wants to communicate with the 8.8.8.8, right? How wanna provide the communication? Then what happened? They came with the concept is called the NAT. They said that, okay, let me do one thing. Let me convert the private to the public. Let me convert to the private to the public. So NAT comes in the picture in the 1994. The first RFC of the NAT comes in the 1994. And it was not a permanent solution. NAT was never a permanent solution. It was just a small solution, like a short-term solution which was there. So initially the NAT was introduced as a short-term solution, right? It was not a long-term solution. But what happened in 2004, right? In 2004, what happened? The NAT was everywhere. The reason is that because NAT was giving the lots of features. For example, NAT is hiding your network. Hiding in the sense of what? So in the sense, take example, if you have a users that's a 191.168.1.1, right? Another user 191.168.1.2. So this is completely hidden by the outside network. So take examples, my switches over there we have, right? And this is the router we have. So, and then we have ISPs over there. So we have a public IP address over there, 101.1. This has a public IP address 101.2, right? So this IP address is totally hidden. This private IP address is totally hidden by the service provider. So NAT has a great features we have over there. So initially they introduced as a short-term solution, right? Okay, let's provide the communication, right? It's not a permanent solution, but when the things was going good, right? Now the NAT is become the permanent everywhere because it has a great feature. Okay, one more thing. What people think about the NAT? NAT provide the security. Even if you read some documents and even if you watch some video and even you go through the books as well and some documents, they will say they will mention that NAT provide the security. Let me correct you one thing. NAT never provided the security. Security means what? What do you think means security? Security means what? My data will be secure. That's the meaning of security. My data will be secure. What people are thinking about the NAT, I'll tell you. When we are seeing a NAT is gonna hide the company internal network, right? So this is my internal network that you can see that 101 and 102. That's my private IP addresses, right? So this is totally hidden by the service provider. So does it mean that we are providing the security? No, we are just hiding the network. It doesn't mean that we are providing the security over there. So many person has a confusion about this thing like, okay, NAT provide the security. NAT never provide the security. It just hiding the network. And what people understand, hiding the network means what? Providing the security. Okay, so we have multiple types of NAT, guys. So if I talk about the NAT, we have a static NAT. 3 types of NAT we have. So if I talk about the NAT, we have 3 types of NAT. So NAT stands for network address translation, right? So we have a static NAT, we have a dynamic NAT, and we have a PAT. So in a static NAT, what happened? We have a 1-to-1, 1-to-1 mapping. So simply one private IP to one public IP, right? In a dynamic, basically what happened? It's a not 1-to, many mapping, right? And in the PAD, what happened? It's a many-to-one mapping. So PAD is standard for port address translation. So based on the port, we are doing the translation. So the private IP is not a routable IP, right? The private IP, according to the RFC 19 address, right? RFC 1980. We have two types of address, private IP addresses and public IP addresses, right? The private IP addresses, it's not a routable address. It's not a routable address. Not routable means what? With the help of private IP address, we cannot reach to the internet. For example, the meaning of this statement is what? For example, we have a 10.1.1. This is the private IP address, right? So we have a switch over there, and we have a router over there. And this is the ISP, right? And there's a network behind the 8.8.8.8. Same way, we have another PC over there. Try to understand, guys. This is very important. We have a 1.1.1. So the difference between these two IPs, what this is the private IP address we have, and this is the public IP address we have, right? So this private IP address cannot reachable. From this PC, I cannot send the traffic to the 8.8.8. We cannot do that. From this PC, I cannot send the traffic to the 8.8.8. But from this PC, I can send the traffic to the 8.8. So I can send the traffic to this guy, but I cannot send the traffic to this guy. But we can provide the internal communication. We do have. So the private IP address is not, the meaning of not routable means what? I cannot send the traffic from here to here. Router cannot entertain the private IP. That's the meaning of routable. Router cannot entertain the private IP addresses. And private IP addresses are free to use. And that's why, this is the reason behind it. That's why it can be duplicated.
Question.
Go ahead.
So, and again, I've never thought of this before, but in that case, let's say in my home lab, right? I bring some Cisco switches and routers, and if I try to use just for the home lab purpose, let's say 192.168, the class C, the private IP addresses, so it won't work in there by design.
It won't
Forget
work.
the internet part.
So I'll tell you what happened. So basically, you have a modem, right? The Wi-Fi modem, Wi-Fi router.
Yes.
That's your connected. So by default, your Wi-Fi router NAT is from over there.
No. No, what I'm saying is, forget the home router, forget the wireless. I'm just saying, let's say I have, let's say two.
Normally you have set up the
home lab.
No, you cannot reach to the internet.
No, not to the internet. I'm just saying I set up a home lab, right? With let's say two Cisco routers, basic routers, and a couple of switches, right? And on those routers, I use let's say 192.168 1.1, and the other one router as 1.2. Now, let's say the end user, let's say if I have a lab PC connected to that R1, right? And if I send a packet, let's say to a PC connected to R2, would that IP address, would the router accept that IP address?
Okay, I understand your question. Are you connected with the internet?
No.
Right? So you are still sending the traffic in internal network, right? Understood this. I understand. So your question is what? Give me 1 minute. Let me write on this thing. I'll complete the question. 1 minute.
Sure.
You have to pay them. Like I have a public, so I took the new public. Remember, when I have started your training, so I have Sony in the Bangalore, right? So Bangalore, I have a different public IP addresses, right? So if you remember that, let me show you this thing. Desktop. So if you guys remember that, in a Bangalore, I had this IP. Is that 126 was there? It's not there. So I had a range with the 126 range, right? In the Bangalore one. So when I took the IP in the Bangalore was a class A, right? 126. When I comes to this one, the Noida location right now, I have this public IP address. So when I set up this public IP address, it took me almost 48 hours, and I'm paying for this one. Now, why I have set up this public IP addresses? So remember, if you guys, I have one server, right? So I have allocated this public IP address to the server, right? So from anywhere in the world, right? Anywhere, for example, Nasir, right? So whenever Nasir is using my server, they are just clicking on this public IP address. They have a username and password, and they are accessing my server. From their location, London, they are accessing my internal network. Now, what Javed, not Javed, I'm sorry. So what Biro is saying that the video statement is this one. I understood the very concept. So let me one more thing. You have to pay the money and it cannot be duplicated. It must be unique. So this Biro is saying that Biro say that they have some router over there, right? Router 2 and router 3. And they have some users over there, switch 1. And they have some users. Okay. And they don't have any connectivity over there to the internet. That's fine. So
Yes.
they have the range, we have 191.168.12.0, and they have 191.168.23.0, right? And this is the 191.168.1.0, pure public, so pure private IP addresses. So you tell me one thing.
Correct.
You tell me one thing. Can they communicate?
Well, based
No.
on what you just explained a minute ago, you said these are not routable, so they shouldn't.
Routable in the sense of
But
what? Internet, it cannot route to the internet.
to the internet, okay.
Yeah, to the
But that's what my question was.
yeah. In the internal network, we can communicate is it. So in this case, if you understand this case, so you are the view, right? So you are the network engineer. You have set up the network. So are you going to define the duplicate IP address in your network? No, right? You're going to assign them must be unique, right? Even if you're going to use the private IP address. So I'm going to use the 2.0.1 over there too. So right now, if I'm going to use the 1.1, I cannot communicate. So I'm going to use the 2.1 over there. So in the internal network, right, you can communicate. But at the same time, if you just have a connectivity with the router right now, a R3 router.
Okay.
And if I'm sending a packet from the router 1, so PC1 can send the packet to router 1, and router 1 can route the packet to the router 2, and router 2 can route the packet to the router 3. But when you send the packet to the ISP, what ISP will do? ISP will receive the packet, they will just drop it because you have a private.
Okay. Okay. So because what happened was, yes, understood. Because what happened was when you mentioned it just a couple of minutes ago,
I mentioned that's not routable, right? So
no. Yeah. So what I'm trying to say is, it occurred to me all of a sudden that all the videos and the textbooks and everything that we have been reading and seeing so far in all the examples, they always in the in the examples they always have these class A the 10.IP addresses
and
with
the class B.
Yeah, right. So I was like, is it that by design the iOS knows that, okay, if it is a private IP address, it is not acceptable as a routing IP address? That's what I was wondering. That's all.
No, so
But now
I'll tell you why.
now I got it.
Now why the books are giving the always standard 0 and 170. So सिलसिला जो जानते हैं वर्ड होता है सिलसिला जो चलते आ रहा है. So that's how the things are.
Yeah.
So in 90s time, they put in the 192 range, 172 range, standard 0. So initially the trainer has followed, then another trainer has followed. Then when I did from my trainer, I have followed the same thing, right? So everyone see, what IP address you're going to use? Have you seen? Even right now, the IPv4 has done, right? There's no IPv4 in the market now available. I'll tell you what happened. When I took my connection in the Noida, I think the Tata connection, right? Yeah. So what Tata will say that the guy, sir, I will give you the free public IP address. Free public IP address, IPv6, but not the IPv4. So I said, what is the price?
Oh, wow. Okay.
So he said that you have to pay the 199 rupees for the IPv4 for public IP address, but public IPv6 address is totally free for you. So we have a huge amount of public IPv6 address, man. Huge amount.
Right.
Market.
Yeah.
But
I was reading about it. It says trillion times trillion. That's how many.
We'll discuss this thing, right? Let's
No. I'm just saying that's many IPv6 addresses available.
If you're gonna assign the one IP to the each particular each element, right? Still you will have IP. That's amount of public IP address we have. The IPv6.
Yep,
it's a huge range, right? Amazing range. again, there's a lots of conversations happen between the IPv4 to the IPv6. There is the IPv5 as well. If you guys remember, I know you if you know this thing or not, there was IPv5 as well. So there was I have a one book I will recommend you. Like if you guys have a time, please go through that book. Not you need to read the whole the documents. You just need to read the maybe the 100 and 200 pages of the book like the pages of the information in the IPv6 book. But that book has amazing knowledge regarding your NAT, regarding your IPv6, regarding your IPv5. Where's the IPv5? What happened? Why the IP comes in the picture? What was the CLNP protocol? It's an amazing book. I'll share it with you guys. Don't worry. I'll upload it in the documents. You can download from there. Okay, let's come to the one. So you understood, guys, right? This point.
Yes, sir. Thank you.
Perfect. So let's come to the point like how you can do that one-to-one static and mapping. So let me open my Cisco package. So one router, you need to perform a translator. So NAT is what? Network address translation. So a router is gonna translate the private to the public or public to the public. So right now, our scenario, we are gonna do the private to the public. When you go with a high level, like when you come to the CSI security, right? Then you will see the use case of the public to the public. Okay, so I'll take the some PCs, right? Okay, I'll take the NAT is only hiding your private network. It's never going to provide the security. Always remember. Security means what? Should we secure the data? It's not securing your data. It's only converting your IP addressing. I'm assuming that so we have a router one. That's a NAT router. And NAT consumes lots of CPU and memory of the router, man. Lots of CPU and memory of the router. Because it's maintained the translation data is stable. So there should be so this is the ISP we have. I'm just assuming that there's a network behind the 8.0.0.0. It's a 10101. Okay, I'll make sure that this guy gonna use the. If you want, I can use the private to the private as well. Okay, so it's up to you. Each server location has its own public IP. It hide the private to be traceable. Is it right? Yeah, that's correct one. So I see the. Okay, let me use the public one. I'm not gonna use the private, but I'll recommend you guys, please do the practical with the private to private so that this concept will be clear to all of you guys. Like NAT is not, it doesn't mean that only private to the public, right? Okay, in interview you can say that, but just for your understanding, okay, you can do this practical as well. So I'm just using the private public range. You can use the private as well. So here I'm going to use the 190. Okay, so let's give the IP, desktop IP configuration. Default, I'll make it so that's 100. No, come on. How did I get the wonderful? All done. So let's do the router side as well. Interface 0/0 IP address will be all that on .2 as well. Make the loop back over there. I'm behaving, assuming that this loop back is by making internet. So on the router one, what I can do that, I'll just give the one default out towards the internet. So that's my edge router. My edge router always have a default again, default route. So this router always have a default route towards this guy, internet side. Right. So now if you see one thing, if I'm gonna ping, understand this concept. If I'm gonna ping from here 1.8 or 8.8.8, I cannot. Right? I cannot do that. The reason why, I'll tell you why, what's happening right now. So you have a source IP address will be 1.1, right? And distance IP is 8.8.8. Source and distance. So when this packet comes to the switch will forward the packet to the router. When the router will receive the packet, what it will do that it will look up the routing table. It said, hey, do I know about the 8.8.8? Router said, hey, you know one thing, I don't have any idea about the 8.8.8, but I do have a static default route, which is pointing to the 1.1.2. So it will forward the packet. It will, ICMP request packet comes to the router number 2. But when it will create the reply packet, in the reply, what happened? It will put the source will be 8.8.8.8, and distance will be what? 1.1.1. When the router 2 will perform the lookup in the routing table, he said, hey, I do not have any idea about the 1.1.1. Then it will drop the packet. So request packet comes over there, but he could not send the reply packet, right? Because I just put the default out from this side to this side. So right now I'm not able to ping, but when I'm gonna perform the NAT over there, I will be able to ping. The reason I'll tell you. So let me do the static NAT first of all. So in the static NAT, what happened? 1-to-1 mapping will be there. So 1-to-1 mapping in the sense of what? One private IP to the one public IP. So like that this way. So for example, what I can do that. So this is my private IP, and I'm gonna map with the one public IP, 101.1.3. Another private IP, I'm gonna map with the another public IP. So that's called the 1-to-1 mapping. So let's do that. So on the router number 1, that's my NAT router, edge router. So IP NAT inside source static, right? The IP is a keyword, that's IPv4 NAT. This I'm doing the NAT. I'm doing the NAT for the inside network, right? That source will be static. Okay, so static will be 101. I'm gonna map with the 101.3. IP NAT inside source is static. 102, 104. So only 2 IP address I have mapped. Only 2 IP address I have mapped. Now understand what happened. Now when this guy will send the packet, understand this concept. So when this packet comes to router 1, what router 1 will do that? Here's the NAT over there, right? So what NAT will do? He will convert this packet like this way now. So source will be now changed with the 1.3 to the 8.8.8. So now the router 1 will forward this packet. So this was the initially original packet, right? This is the NAT packet. So when this packet comes to router 1, router 2, what router 2 will do that? When the router 2 will create the reply packet, in the reply, what they will do that? Source will 8.8.8, destination will be what? It's a 1.1.3. And 1.1.3 is what? It's a locally one, right? Sorry, not 1.1.3. Yeah, 1.3. So locally routed over there. It will forward the packet over this guy. It will forward the packet over this interface to the router 1, and router 1 will send the traffic to the PC number 1. So the PC 1 can dish to the internet now. If you ping, he can. Oh, I'm so sorry. I missed the one point again. So basically after that, what happened? Once you put the command, then you need to define the zone over there. So basically this is the one area we have. This is the another area we have. So this is the NAT router. So for the LAN area, we are called this guy the inside area. For the WAN area, this is the LAN area, that's called the inside. For the WAN area, that's called the outside. So you need to mention that, this thing, under the interface. So interface 0/0, IP NAT inside. And interface 0/1, IP NAT outside. Now you can ping it. So this interface 0/0 is a LAN interface. I said the inside. The WAN interface is the outside. So we need to call as a outside NAT. So now we are able to ping. I did the mapping for the 101. That's why 101 can send the traffic to the 808. Let's do the ping from the 1.2. So 1.2 will also send the traffic. The reason is that I did the mapping for this guy as well. And with the mapping for this guy, I can send the traffic. But how about this guy, R3 and R4? Sorry, PC3 and PC4. Did I perform the mapping on the router one? No, I haven't. I just did the mapping for this two IP address. So if I'm going to send the traffic from the PC3, I cannot. That's a problem of not a problem, I can see that, guys. That's a limitation of the static net. It's not a problem, it's a limitation of the static net. Okay, so that's why we came with the dynamic net concept. So how the dynamic net works over there. So in the dynamic net, we don't have a one-to-one mapping. So what basically we can do that, we have a bunch of IP addresses over there. The public private IP address, so 1.3 as well, and 1.4. Now in this case, what happened, right? This is the bunch of private IP. So for this one, what I can do that, I'm gonna purchase the pool of public IP address. The pool of public addresses. So this is the pool. The pool name is the ABC. And in this pool, I will put the public IP address will be 101.103, 101.4, and 101.5. So this is the pool that I have purchased from the ISP. So whenever this PC, take example, whenever this PC wants to communicate, they will take the one IP address, 101.103. Whenever this PC will communicate, they will take the one IP address, 101.4. Whenever this PC will communicate, they will take the one IP address, 101.5. So if all this IP will be exhausted from this pool, then the PC port cannot send the traffic, because for the PC port, we don't have a public IP address in the pool. So when the PC3 will stop the communication, then what happened? They will release this IP. And now when this PC will gonna ping the 8.8.8, they can take the IP address from this pool now. So it's like a what? It seemed like a DHCP concept, dynamic host configuration protocol. Whenever user need IP address, they can request for the DHCP. Hey, I need IP addresses. So the DHCP will give the IP to the PC. Same thing, whenever this PC wants to communicate with the internet, they will request to the NAT, hey, I need a public IP address. So if the public IP is present in the pool, they can allocate it. If they don't have, then he will say, hey, wait for some time. If the another person will release it, then I will assign to you. So that's a good point. So after the static NAT, the dynamic was a good one. But still in the dynamic, what happened? Still in the dynamic, we have a limitation, right? Limitation is what? We need to purchase the bunch of public IP addresses. We need to purchase the bunch of public IP addresses. So let's see how you can kill the dynamic NAT. Same concept, what you can do that. Let me copy this configuration first over the notepad so that you can have a note. So on data one, right? So that's my static NAT. Always remember, NAT never provide the security. How the dynamic NAT is going to work? So in a dynamic NAT, first of all, we have a pool, right? If you have a pool, then I also need to allow what network I'm gonna allow. So we need to create the ACL for this one. So two things we need to manually create, pool and ACL. In the ACL, we are gonna match what traffic should we go on the internet. So let me remove this configuration first of all. No. No. And as the IP NAT in IP NAT pool ABC, and in the ABC, I'm going to define the IP address range will be 103 to 105. You can also use this IP, the interface IP address, as a NATed IP address as well. If you want, you can use it. That's the subnet mask information we have. IP NAT access list, one permit. I'm going to allow this guy. So two things I did it. So I just create the IP NAT pool, ABC, and I'm sorry. And then I can use it over there. Right? And then now the final, the task is what? I need to call both the things in the NAT. IP NAT inside source. I call the list number, the list number is one is the ACL number, then pool number is the ABC. That's all. So inside and outside is already applied, so I don't need to call again. That's all. This is called the dynamic NAT. So now you can see that PC1 can send the traffic. PC2 can send the traffic because we have three IPs in the pool now. The pool is a 103, 104, and 105. So one PC took the 103 as a NATed IP. One PC took the 104 as a NATed IP. This PC can also communicate 105. But the PC4 could not, because all the users took the public IP, but we don't have a public IP for this guy. So this will be exhausted. So this NAT router is gonna maintain the translation table as well. So this is how the traffic is going like 103 to the 101, 103 to the 101, 104 go to the 102. And then if you can see the bottom, you will see the 103 as well. 103, that's go with the 105. 102, that's go with the 104, and the 101 is going to 103 as well. But the problem is that the dynamic NAT is what? The problem in the dynamic NAT, it's a limited. Scalability perspective, it's a very bad. Because still now, take example, if all the users simultaneously gonna use the internet, then this PC has to wait. So that's why we have come with another problem that we need to purchase the multiple public IP addresses. So take example, we need to pay the money for this guy, 200 rupees, 200 rupees, and 200 rupees, 600. And just for the small network. So that's why we came with the solutions called the PAT. PAT is standard for port address translation. It's not a network address translation, it's a port address translation. So based on the port, we are doing the translation. So how you can do that? So in the PAT, we just need to have a one public IP address, not the multiple. So the first we need to remove the command. Where's the pool that I created? Yeah, so now the same step. So in the PAT as well, what I can do that? right? In the pad as well, we are gonna same thing. We're gonna give the pool of that. But in the spool, we don't have a bunch of IP address. We just have a one IP address. Then what? We still need to get the ACL to match the route. And then what? Same concept. I just need to get this guy. Same configuration. Only we need to change the few things. What? Now we don't have a lots of things. I just have a one public IP address. So I can use the same public IP, one-on-one as well. The interface IP address to the one-on-one. That's all. So start with the one-on-one, end with the one-on-one, and then set net mask will be this guy. Permit this guy and pull. That's all. And pull ABC, and then I'll mention the overload keyword. Simple. So I just call the starting IP address will be one-on-one, end with the one-on-one. That's a starting range and range. So I'm just using the one IP address in the PAT. In the PAT, if you see the configuration are pretty simple, right? Same steps. Only the thing is that we need to add the overload keyword in the last. That's going to represent the PAT. Now we are good to go to send all the traffic, man. A.PC1 is sending, PC2 is sending, PC3 is sending, and PC4 is also sending. So even if I'm going to add another PC, I don't have any issue, man. Even if I want to add another PC and with the another IPS, right? Make sure that the same subnet 1.10. I can send the traffic. That's a beauty of the PAT we have, port address translation. So with the help of one public IP address, right? All the users, all the internal users can communicate to the internet. Why the packet is getting dropped? Because of the spanning tree, right? Can you see that it's an amber strip? Now it's coming in the green. So because of the spanning tree. So that's how the PAT comes in the picture. So this is the three steps, right? Sorry, three ways: static, dynamic, and the PAT we have. So in the PAT, what happened? If you go in the translation table again back. So this translation table is valid for the 24 hours, guys. This translation table is valid for the 24 hours. So the till the 24 hours, this will be available. Again, it's going to consume I read some of the documents, right? I don't know which documents I read it long time back. I think so 3-4 years back. One translation table, right, is consuming almost 100 to 200 bytes of memory. And there was one issue. One of my students had an issue, right? So I think so it's Nigeria, right? So he called me that, hey, law, like, my router, we are getting some drops in, no, not drops, we'll say that. Yeah, they had some memory allocation issues in the router side. And then I asked for this command, so IP NAT translation, and he showed me that. And there was a bunch of, right, translation table there's a bunch of list of the translation. So I said that do one thing, just remove the translation, right? Whatever the requirement is not there. So because it's going to consume the lots of memory and CPU, because one entry is consuming almost 100 bytes plus. If you don't have a communication right now, if you have a still entry, still means what? Still entry means what? The entry that is not using right now, the PC are not using for the internet communication. Just remove it. Okay, that's in that way you can save the memory. So simple command. It's gone now. So that can save you lots of memory. But don't do that in the production until unless you don't have a problem. Okay, if you have a problem and if you have a guidance from your manager side on upper label, then you can do that. Otherwise, don't apply this configuration, because if you're going to apply it, then you will have a traffic drop in your network just for the timing, a small amount. All good. Let me show you the books that I want to show you that. Let me pause